Welcome to IT Pro TV. I'm your host, Don.
Coming at you live from San Francisco, California.
You're watching IT Pro TV.
All right, greetings everyone, and welcome back to another great episode of IT Pro TV. I'm your host, Daniel Lowry, and I hope you're just as excited as I am because today we're continuing on with more in our A+ series, and joining us back again to be as excited as we are, hopefully, is our good friend, Mr. Wes Bryan. Wes, how's it going, man?
Man, it's going great. Yeah, this is going to be, it's going to be another good episode in our mini-series on networking troubleshooting, right? We've been talking about wired and wireless and some of the things that you can encounter, and there are just a handful of things that we kind of want to wrap up here, so this might not be a very full episode, but it's definitely going to be full of a lot of great content regardless. So
it's going to be full of something.
It's going to be full of something, that's for sure. That's right. Let's hope it's something that you guys want to stick around for. That's right. So one of the things that they've also talked about when it comes to some of the symptoms you can get inside of wired and wireless networks really is slow transfer speeds, right? When we talk about network, remember, networks are here for two reasons, right? Communication and then sharing resources. And one of the things that we do from time to time on networks are share things like files, right? We transfer information from one computer to another. And sometimes those file transfers, if you will, or transfers in general, slow transfer speeds can happen. Now, there's a few things that might cause this, right? The device, let's say you got a network device out there, it's got a hard drive, and that hard drive is starting to fill up and we're really full, right? Well, understand that the operating system, whether you're transferring files or not, is constantly using your hard drive, right? We have what are known as page files, swap files that we talk about in 902 that allow us to use portions of our hard drive as memory, and your operating system is constantly using that, right? When you talk about things like sending information to network-based printers, if the device is a printer that's connected to another machine and that drive is full, you might start to see some performance issues there as well. So it could be the fact that the storage media maybe the storage media is using old standards too. That could cause a problem too. Your cabling, right? Could be another thing, standards, right? We try to shy away from Cat 3 today just because of its limited bandwidth, right? You want it really today, you almost want to go with nothing less than Cat 5e. I know a lot of people say, well, if I'm going to install new cabling, I'm pretty much going to go with Cat 6 or above, right? And it does get expensive, but it could be a standards, right? The standard could be causing the problem too. You could have limited bandwidth, right? You could have, a lot of devices as well going along with that mindset is that you have a lot of high definition video that's traveling your networks. And guess what? You need some bandwidth, right? That takes a lot of that theoretical pipeline, if you will, to send information through it. And if you have a lot of devices that are on your network all doing that at the same time, then you'll have bandwidth contention, right? Because keep in mind, when you're talking about on a network, it is shared bandwidth. And too many devices, again, can cause a little bit of contention. The other thing that you could have too, and this is not quite as common, but could happen, is duplex mismatches, right? We have a few different types of duplexing technologies, right? Duplexing is, can I send and receive information at the same time? Well, if I could send and receive information at the same time, that's called full duplex, and that's what most of your modern networks for a long time have been, full duplex. I can send information to Dan's computer as well as Dan can send information to my computer, and we can do that simultaneously. In the earlier days when we were using things like hubs, this is another one of the reasons you don't want hubs for networking devices, is that they were half duplex, right? Think about what we said in the characteristics of TCP/IP when it comes to hubs, right? A hub, when you send communications into it, it basically broadcasts at all ports, which means that if I'm communicating with the hub, Dan's computer has to wait till I'm done talking in order to communicate. That's a half duplex communication, and it causes slow transfer speeds. However, we usually don't have that problem today, again, because the majority of the time we are configured for full duplex, and a lot of times it's auto-negotiated, which means when my computer connects to the network, it talks to the connectivity device and says, what are you running? Well, I'm running a gigabit speed and I'm running at full duplex, and I'll go ahead and configure that adapter. The operating system will for you. Proximity, if it's wireless, could be proximity to the access point. Again, the farther away you get from the range of the access point, the slower the performance could be. It could also be things like obstacles in the way, right? Wireless communication, while not really needing to be a completely direct line of sight with Wi-Fi, it doesn't do too well when we talk about walls in the way, right? That could affect performance too. Could be things like electromagnetic interference. Radio frequency interference could cause problems, right? And really, when you talk about electromagnetic interference, we're talking about affects wired cabling too, right? And what do I mean by that? Well, it's really easy to get a little bit lazy when it comes to wiring your network, and because you already got an electrical outlet, well, that cable, that conduit's running through the wall, so let's just go ahead and let's put our Ethernet cable right next to the electrical conduit. Well, that can cause electromagnetic interference, right? That crosstalk, that bleed over the electromagnetic energy from the AC source into your network communications. The other thing that can cause that as well is if you're running things like, for instance, maybe you've got some high-intensity discharge lamps, you got the fluorescent bulbs inside of your home, you've got a drop ceiling if you're in a business, got all fluorescent lamps. Fluorescent lights give off an extremely high amount of electromagnetic energy, and they also can affect data transmission. So keep in mind that could slow things down too. And notice I saved this one for last because I think, Dan, I think you mentioned this in an earlier episode. We always want to call this one out first, right? Malware. But we can't overlook it, right? Slow transfer speeds could be malware. You could have some kind of worm on your network that's replicating itself across all of the different devices within your network, consuming your resources, and really slowing things down and causing havoc, right?
Yeah, it's never a fun time. I've had many a help desk call where someone says, oh, my computer is running slowly. I'm like, was it your computer that's running slowly? Is it your network connectivity that's running slowly? And to come to find out, usually it's both if it comes to malware, because it is just hogging resources and slamming your network home because it's phoning home somewhere.
Yeah, definitely. And that's what it seeks to do, right? Consume anything it can and everything it can, and it will.
It is the devil.
It really is. And we've got to watch them, right? Because as you'll learn when we talk about security, a worm is a self-replicating, self-generated type piece of code that is self-sufficient, if you will. It just needs a port of entry. It doesn't need a host like a virus does, but it could be viruses as well. Now, the other thing they call out is low RF signal. Low RF signal also can manifest itself in slow transfer speeds and can be intermittent connectivity as well as poor performance within your wireless networks. Now, when we say low radio frequency signal, you might have the wrong antenna. You might have a non-directional antenna, omnidirectional antenna that's actually being blocked. You might have to change antenna types. You might have to change the gain of the antenna itself, right? Gain is the signal strength, if you will, and that could be a problem. Could be proximity to the access point as well as obstacles in between you and whatever the transmitter is on the back of the connectivity device, right? The other thing, too, you've just got to have limited bandwidth, right? You might have too many devices, if you will, within your network. So be very careful. When I say you have to increase the gain of the antenna, I'm not necessarily telling you have to get into the access point and start modifying these settings, because these are advanced settings, right? You really have to be a wireless expert. I don't know about you, but I set mine to auto and I leave it alone, right? Because if you don't know what you're doing, and I'll tell you, be the first one to tell you, I have a very limited knowledge of it. If you increase the gain, you also increase the likelihood for interference. So there's a really fine balance to doing that. But one of the things you can do that's relatively easy and why they become so popular, wireless range extender, right? Just pop that into an electrical outlet and extends the range of your wireless network. Very simplistic, and it doesn't require a lot of setup. So there's some things that you can do as well. The other thing they call out is what is known as an SSID not found. Now, when we talked a little bit about wireless, we mentioned what a service set identifier is, right? Here's one of those, just like we were talking about, like with pre-shared keys, PSKs. Here's another technical name, right? SSID. It's a network name, right? It's what identifies the network that you're trying to connect to. And your wireless adapters within your devices, typically what they do is they send out what are called these STA probes, right? That's a station probe. That's your wireless device is the station. And it's just sending out these signals. It's saying, hey, any access points out there? Any access points out there? Well, the access points like the one that we've been using and all the really all the access points, they're listening out constantly for that communication. And they say, oh yeah, let me send you back some information so it lets you know that I'm here. Right? In fact, if we take a look at my computer here, I've got my wireless adapter on right now, and you can see there are a ton of the access points that are in proximity to this network adapter, right? And this is what is happening. My computer, my wireless adapter is saying, hey, anybody out there? Anybody out there? Anybody out there? And all the access points that are within this proximity, they're going to respond back. But there is a time when maybe your access point that you are looking for and not all these other ones that we have out there doesn't show up in the list, right? I want you to focus in on this one, Skynet. Yeah, and for some of you geeks out there, recognize that name. That's right, Skynet here. Notice that I can see it. Well, that's directly related to the configuration of the access point itself. And in fact, I'm in the basic wireless settings here. And more specifically, I'm in the 5 gigahertz frequency. It works on 2.4 gigahertz as well. Notice that SSID broadcast, right? Notice that it is being broadcast. Well, and it is enabled. Sometimes you can see that it'll be disabled, right? And if it's disabled, and we'll go ahead and save these settings, let the configure, oh, it looks like my session timed out here, so let me show you guys, if you didn't know how to log in, probably shouldn't be learning from me, the way I type. Notice that I can turn around and I can disable the SSID broadcast, and we'll go ahead and we'll save these settings. Now, it might take a second for my wireless adapter to update because it kind of bookmarks stuff and then it refreshes itself just to make sure that different access points are still within its proximity. And let's go back up here, and I don't know if it's, and it's still there. Let's see, I'll tell you what, we'll force it. We'll see if we turn it off. We get no information. Sometimes it bookmarks that, and so let me just tell you that sometimes it might stick. And we'll turn it back on, and it does look, I'll tell you what, maybe I can forget this network altogether. It doesn't look like I can. So sometimes you can forget the networks that are in here. This one looks like it is going to stick here, but we can also do another thing here. And did that? Yeah, that disappeared. There we go. There we go. So it did disappear. Right. The other thing that you can see too is you can use something like a wireless locator. So like for instance, Mac, there's all different kinds out here. I got Wi-Fi Explorer here. Wi-Fi Analyzer is a great one because that's in things like your Android platforms and your iOS platforms for mobile devices. But you might notice, and I certainly don't expect you guys to pause the video or take the time to look in this list, but if I scroll down here, one of the things that I'm not seeing is that Skynet, right? I'm not seeing it in the list, whether it be in a wireless locator, and it does look like it kind of came back there. So we might have, oh, you know what that is? I know exactly what that is. That's the 2.4 gigahertz network, right? So the 5 gigahertz network disappeared, right? Yeah. And you've seen it disappear. But the 2.4 gigahertz network is still broadcasting, right? So again, you can see that the way I've got this filtered by the 5 gigahertz, notice all the 5 gigahertz range is at the top. And if we look in this list, we don't see Skynet. So that could be the reason, and a lot of times that is the reason. Now, there's conjecture on this one, so I'm gonna probably throw a pond in an MMA, or a rock right here in the middle of an MMA fight. Some people say to disable it for security purposes so that you don't find it in the list. Other people say that only keeps the legitimate people out of your network, because if anybody knows a lot about wireless networking, they can still find this information. However, when we say keeping the legitimate people out, people that need to connect to the network can't find it simplistically in their network adapter. They can't connect to the network, and it causes connectivity issues. So do keep that in mind. All right, Dan, I know we've been talking about a lot of different things. I do want to just kind of mention a couple of the software-based tools that we need to talk about before we wrap this one up. And this is something that essentially what we can do is we can see inside of our operating systems. Now, there are a handful of technologies or utilities that you have out there. Some of them we've kind of talked about. We mentioned in earlier episodes, we kind of showed you how to use ping as a utility. We've shown you how to use things like ipconfig. Keep in mind that there's other ones out there too. ipconfig is in Windows. I know they have an older one there in Linux, ifconfig. They also have IP as well that you can use, and these show you the statistics of the configuration of your interfaces. And in Windows they call it ipconfig because it's really just showing you the IP configuration. But we also have other utilities too that can test connectivity. One of them in Windows is called TraceRT, and in fact, I'll tell you what, we'll go ahead and we'll open a command prompt up here, and let's see what exactly TraceRT is all about. So I'll go ahead and I'm going to launch a command prompt here, hopefully. And when we launch command prompt, we're going to go ahead and apparently launch a whole bunch of them there.
You went crazy.
That's right, that's right. And we're going to run TraceRT. Now, TraceRT does something a little bit different than ping, even though underneath the hood it's using the same protocol. TraceRT allows me to trace the path a packet takes from source to destination. That's what Microsoft calls it. If you're in Mac, if you're in Unix and Linux-based systems, it's called traceroute, and that's why even in the Windows, Windows environment, a lot of times we just call it traceroute, but they spell it TraceRT. Now, TraceRT, again, let's say I'm using the ping packet, right, and I realize that I have connectivity out to the internet, I ping that remote network, but for some sites, I just can't seem to connect. Well, you can actually do a trace RT and you can find out where the breakdown is. So if I do a trace RT here and I do a 4.2.2.1, provided that your firewall isn't blocking this type of communication, and honestly, that might end up happening here, that it might, it's actually making it at least to our default gateway. Okay, there we go. It's getting out there. Sometimes for security purposes, ping and trace RT can be blocked. Well, I can actually use this information, and if I start to see asterisks here and it says request time down, a couple of things could be happening. Could have a firewall, could have security purposes. They don't want you to find this information, like we see right here. Or it could quite literally be the fact that your communication is stopping right there. In this case, I would almost guess, Dan, that they've got some kind of firewall that doesn't want to show you that information. Now, if it was to continue this way with these little asterisks here that we see, that would lead me to believe that the reason I can't connect is somewhere along that route between my computer and wherever it is that I'm communicating, we had the proverbial communication breakdown, right? Something was going wrong. And that's one of the great things. You might ask yourself, well, I don't know any of this information. And you're right. A lot of times you don't. But for us here at the IT Pro TV studios, we can tell that that is our firewall that we're going out. So we can recognize that IP address. We also know that these are our local internet service providers, right? We talked about in another episode how you got that hierarchy of internet service providers. Well, we can tell that when we jump on GRUCOM, GRU here, that's our local internet service provider. And the thing is, if we see that failure happens there, right? One of our tech guy here, Nate, he can get on the phone and he can call GRUCOM, right? Don, one of the other hosts here, can get on the phone, call GRUCOM and say, all right, what's going on? We see that we're not connecting. Now, you will see other ones in here, and if you look at these, right, this is level 3 out in Miami. This is an internet backbone provider, and this is one of the biggest network operation centers in the United States and really probably in the world, right? This is A Resolvers here. This is level 3. This is another internet backbone provider, and what I just pinged was a root hint server, right? One of the big dogs. If there's a breakdown in this area, there's really nothing you can do about it, right? They knew about it before you ever discovered it, and they have the best technicians in the world, and they're handling it, right? But it gives you an example where you can see some of that information.
Yeah, that hop we lost is probably their load balancer.
Yes, definitely. Behind, and again, for those security purposes, they don't want you to know some of that infrastructure there. Now, there are some other commands that we want to kind of talk about. In fact, let's go ahead and let's see. I'm going to fire up Internet Explorer here, and we'll go ahead and let's connect outbound to, I don't know, let's see if we can connect to something like Google. All right, and it is going to do what it wants to do regardless. Thank you, Internet Explorer. All right, so let's go ahead and we'll do that. We'll type www.google. I might need a search engine to help me out with this one. And we'll connect to Google. Now, if you make a connection to another computer, you can actually see that information in something known as NetStat. And NetStat here is network statistics. And if I type a netstat-a, it'll actually show me all of the states of TCP and UDP connections that I have currently on this computer. Now, I do want you to understand that UDP isn't going to send you, you're not going to see any information in UDP because UDP is stateless, right? It isn't a connection-oriented service, but some of the things that I can see are those established connections that we have here, and I could see some of them right there going back. Who knows? This is probably some kind of web crawler in the background for all we know, but I can see those established connections. That is one of the tools that you have inside of your Windows operating system. All right, a couple more that we want to kind of talk about. There's another one that's more for a legacy service today than it is for a more modern service, and that's something called NBT Stat. That is short for, and this is I love this one. It's easier to remember the shortened version. That's NetBIOS over TCP/IP statistics. And when we needed to find out information about NetBIOS names and the resolution of the services that are provided, we could use this type of command, right? You'll probably see there's not a lot of information here. I don't know that this is going to be too specific for us. In fact, let me go ahead and do a -a here. All right. Oh, and did I not do that right? Looks like we've got NBT stat -a, and maybe I don't know. Maybe I put a space in there when I shouldn't have. NBT stat -a. Oops. We will get this right eventually. Doesn't look like I have. Oh, it's giving me a hard time for some reason, but I don't see. I know one other one.
IP address or a remote.
Yeah, well, there's another one I'm going to go ahead and run. I'm going to run -R here, and -R usually will give you some kind of information. Looks like my computer is running a little bit slow here. Got to love that. Yeah, and I tell you what, I almost know. Bet you I know what it is. Windows is probably running an update in the background, and it loves to do that on you. But there is one other one that I'm going to run, MBT stats, and that is the -r, and that gives you a little bit more output. It could be the fact that I don't have any remote lists names in that list, so it's saying there's nothing to show you. I think one of the main things, other than remembering that this is specific to NetBIOS-based names, if you see, and you've seen it quite a few times because I couldn't type right, the fact that, I'll go ahead and run this and let it show me the output. I could have just run a / question mark, but it'll do the same. I think the big one, Dan, on this one I want you to remember is in Windows, most things aren't case sensitive. In Linux-based systems, Unix, Linux, you better get used to case sensitivity. It is very important. In Windows, it isn't, except for this command. Notice there's a big difference in here. We've got a little a, lowercase a, we got uppercase a. We've got a lowercase r, which shows me the list that I just pulled up, versus the uppercase r says, just go ahead and purge that list. Big difference, right? So definitely no MBT stat. That is one that you can do. There's other commands out there like net, and I'm going to go ahead and run this by itself so we can see some of the options that you can do. We use net. Like for instance, net in combination with net use to map network drives so that I can I can connect to these shared resources out there on our networks. You also have another one that's again it's still there, netdom. Oh, and you know what? It looks like it's actually been taken out. NetDOM is a way, and we can also do this with the net command. NetDOM was a way that you could join a Windows domain, right? It's in the list. Again, we're using things like PowerShell and stuff today, so I do want you to be aware that it is there. Know the other ones that we've also talked about too. Again, ping, ipconfig, ifconfig, traceRT, mbtstat, netstat, as well as netdom. Last one I want to talk about when it comes to the software-based utilities is something known as NSLOOKUP. NSLOOKUP allows you the ability to see if your computer can do name resolution. Remember what DNS is doing for us? DNS is taking a fully qualified domain name and mapping it to an IP address. So if I need to figure out, can my computer do name resolution, I could type NSLOOKUP. And let's say www.google.com. We'll see how fast this resolves. Again, I think it's probably doing some updates in the back. It wasn't too bad. And I can see that the name www.google.com resolves to this IPv6 address and IPv4 address. If that didn't happen, then we could see, we'd check the TCP IP properties in the network adapter and find out if we've got an IP address that's misconfigured in manual configuration, or maybe I don't have the default gateway set up right and it's not passing the DNS information through to the DNS server.
Well, Wes, we have a bevy of different software tools that are ready to be able to troubleshoot some of these network connectivity issues. But we also have some physical tools as well that we might have to employ.
Yeah, definitely. They call out a few, right? Because sometimes it's a logical issue, right? And sometimes you got to go Spock on it. That's a logical, Captain. Sometimes it's, again, a physical issue. And thank goodness we got a whole plethora of them sitting here on the table here. So if we can take a look, you can see some of the kinds that they call out, right? One of the kinds that they call out is what's known as a tone, they call it a tone generator and a tone probe. Sometimes it just emits a light. Sometimes it does emit an audible sound. And what this does is essentially you can plug this in to the cable, and you can go over to basically a spaghetti-sized bundle of cables, and you can touch the tone locator to it. And what happens is when it comes in contact with the electrical current that the generator is providing, it emits an audible tone, right? And that might not make sense when you have just one or two cables, but literally out of the wall, when you have 400 of these cat cables and it's a
which one's mine?
Right, exactly. Which one's which? And it's a 300-pound bundle. You certainly don't want to take the time to go through every single one. So tone locators, if you will. They call it a locator and generator. It's typically one and the same unit, and one, it basically generates an electrical current, and the other one emits a tone when you touch it to the wire and you find the cable that's got that electrical current going through it. A couple of the other things that we have here on the table. We've got what's known as a cable crimper, and there are a couple different kinds too, right? This is one that is an RJ45 and an RJ11 crimper, right? The RJ45 being the bigger one for Ethernet. Next to it, its older, smaller cousin here is the RJ11. That's for the traditional phone lines. And again, what you would do is you wire the cable according to, in this case, let's just take RJ45 for an example, or the 8P8C connector. You would take and you would wire it either 568A or 568B. You'd put it in here and you'd crimp it down, hence the name, right? The other thing that you have as well is you could have something like a coaxial connector here. And this is one where if you are using, like our production team here has to use this quite a lot. They run some crazy cables. I've seen them make cables that actually come down off of a 24-foot tall, building off of the roof into the back of a soundboard, right? And that would be your coaxial cable, and you put your BNC connector here, run the coaxial cable into the background, and then crimp it down, and it essentially attaches the coaxial cable. Now, they call out a couple of different things. They call out wire strippers, and there's all different kinds. I kind of use these right here because I like how thick they are, but there's also cable strippers too. And this is an example of a cable stripper that would prepare the coaxial cable. However, I will say, guys and gals out there, this one has a cable stripper right in there, right? You can almost kind of see it, and in fact, you're going to see here, if we can zoom down in, I actually use this to kind of show you guys the cables here that we're going to run the cable tester on, right? So another cable tester that we have here in the studios. Now, this cable is good, and we can tell that by plugging one end in. This would also work on a coaxial implementation too if you wanted to test the single copper conductor that runs through it. In this case, when I turn this on, it's going to send an electrical signal down the 8 individual conductors in the 4 twisted pairs, and it is going to be something that it lets me know, in this case, hey, it's good, right? Reversal can happen, and I've actually done this on quite a few occasions. I don't know if I should admit to that here in the show, but you can ask any one of the hosts. Sometimes I'll get too quick putting that RJ45 jack, and maybe I won't put the conductor right down onto the connector when I crimp it down, and it'll let you know. Sometimes you reverse it. Sometimes you can have something like this. Now, guys and gals out there, I wouldn't ever suggest doing this if you got one of your good connectors. But let's see here. Let's see if I can cause a break in one of these. I'm not sure. There we go. Notice that we've got now a pair that don't have any lights coming on, right? That
got 2 pair.
Two pair. That's right. We got 2 pairs. So I did a pretty good job on breaking that one, right? And it's letting me know now that we don't have connectivity. And this also goes, I want to go ahead and shout out to Jim out there in the chat room, says you got to be very, very careful in not nicking these wires because even the slightest little cut in the shielding itself can cause electromagnetic interference, and especially when you're talking like Cat 6 and above, Cat 6A, and when you're going for things like gigabit speeds, there's almost zero tolerance for any kind of nick in the sheathing, let alone as drastic as I've done here, where I've actually cut one of the cables in the list or in the bunch. If we could zoom in just a little bit farther, you guys can kind of see this. It lets me know what I should be looking for when it comes to the actual 568A and 568B. It lets me know how the wiring should go. So if you ever needed kind of like a guide for the standard, you can always Google this too. But this is kind of nice because it tells you what pins 1 and pins 3 should be, right, versus pins 4 or pair 4, pair 5. Down here you can see with the blue pair and the brown pair, a lot of times that's your ground versus your transmit and your recipient or receive pin. So a couple of the different connectors, and again, you can see here it supports things like, for instance, your RJ45 jack, as well as if you're doing some kind of BNC work as well in audio communications. All right, Dan, I know that we have run the gamut when it comes to a lot of the different things that you can see. Hopefully, we've shown you a good bit of symptoms and some of the things that you can do to remediate, identify and remediate those symptoms, as well as some of the logical and software-based tools that you need to know on the exam, as well as some of the physical tools that you have out there when it comes to maintaining those networks and keeping them running like they should.
All right, Wes, well, we do appreciate you running us through these tools and symptoms that we might encounter when network connectivity is the issue. That being said, it looks like we're out of time for this episode. We do thank you guys for watching. Hopefully you've enjoyed it and learned a lot. Signing off for IT Pro TV, I've been your host, Daniel Lowry.
And I'm Wes Bryan.
And we'll see you next time.
Thank you for watching IT Pro TV.